All right, evaluating factor operators. So factor operators affect the value of a factor. So this is huge because it actually changes the value of a factor. And we need to know those factor values before we can understand anything about a term, because factors make up terms. So you're going to see symbolism that looks like this, the opposite of, and we have a negative sign with the parentheses. Um, so the parentheses are signifying a factor. This is basically saying take the take the opposite of the factor. So some examples you might see, if we had the opposite of, and inside we had number 5. So the factor is 5. This actually changes then. The opposite of 5 is -5. So the value changes to a factor of -5. So if we had something like the opposite of -3, again, we see the symbolism, the opposite of. Well, this factor then is going to change to a factor of just 3. So the opposite of -3 is the same as +3. So again, we want to be able to read these. So this one would be read the opposite of -3. So again, we'll get used to that negative sign, but sometimes the negative sign means the opposite of. If it's in front of parentheses, it will always mean that. It has to have the parentheses in order for it to be an operator. This is the opposite of -3. So the negative in front of the 3 is just representing the value of that integer. So absolute value is another one. The absolute value, which is signified by 2 parallel lines. First of all, absolute value, what it means and what it represents is the distance from 0 on the number line. So if we're looking at, say, the absolute value of 4, then what it's asking, what it's saying is that how far away from 0 is the number 4. So the absolute value is the distance from 0. Well, the distance is a positive value. So the absolute value of 4 is just +4. So the absolute value of 4 really, in this case, doesn't change the value of the factor. But if we had the absolute value of, say, -2, then -2, how far away from -2 to 0 is it? And again, distance is positive. Distance does not have direction, so the distance is 2 units. So the absolute value of -2 actually is just +2. So it changes that factor value to positive. So when I talk about we have an operator, it affects the value of the factor. Um, it changes the factor value then to what the operator does. So the opposite of changes it to a factor value of over here, like um, the opposite of -3, the factor value then is 3. Sometimes it changes it, sometimes it doesn't. The absolute value of a number, if it's positive, it's just the same as the positive, so or it's just the same as the number. But, so these are operators that are changing the factor value. There's a couple more that we want to look at, factor operators. Exponents, if I can get this here. Exponents. or powers. Well, exponents and powers represent repeated multiplication, either factor counters. So we might see a factor of 2 raised to the fourth power, and we'll see this exponent. And what this is doing, and again, it is an operator, it changes the value of this factor. It actually represents 4 factors of 2. So if we rewrote this, we would have to write it as 2 times 2 times 2 times 2, or 4 repeated factors of 2. Um, so to evaluate a whole bunch of repeated factors, it's just easiest to do 2 at a time and keep track. So 2 times 2 is 4, 2 times 2 is 4, just grouping them as in twos and keeping track. 4 times 4 is 16. So this factor value, 2 to the fourth, actually changes to 16. So we could either rewrite it as all the factors or leave it and find the factor value. So this is the factor value of 2 to the fourth. So again, the exponents then would represent repeated factors or a bunch of different factors. So a lot of times you might see like 2 to the third power and then like times 3 to the second power. So we kind of use these to write the factors a little more compactly. So instead of having to write um, 3 factors of 2, which would be 2 times 2 times 2, and then also 3 factors or 2 factors of 3 would be 3 times 3. We use exponents to make them a little more convenient. But either way, it doesn't matter. Then square root is another factor operator. And the square root is basically the inverse of squaring something or taking something to the second power. So when you see a square root symbol, you're basically asking yourself, what squared gives this factor? So if you think of like the square root of 16, so 16 is a factor and the operator is the square root. What do I square to get 16? And if I look down here, 4 squared is 16. So the square root of 16 actually gives me a factor value of 4. So this operator is changing the factor value of 16 to 4 because it's the square root. So the square root, again, is something that we see a lot. It changes the factor to a different value. If you look, then if we're dealing with square roots a lot, we need to get comfortable with recognizing perfect squares, numbers that are perfect squares, right? So we could write this list and get used to seeing perfect squares. So like 81 is a perfect square. It's 9 squared. So if I take the square root of 81, then I know what do I square to get 81? The answer is 9. The same thing, 121 is a perfect square of a number. So if I take the square root, I know it's 11. So with working with square roots, you definitely need to remember and practice with your perfect square numbers. All right, your factor operators, opposite of um, powers, square roots, and absolute value. So they're effective value of factors, and we need to know those to be able to change them. Okay.